Hello friends, good evening. My name is Vishwadeep and I am here to teach you computer organization and architecture course for GEET Computer Science, and I am here to teach you today another session for addressing modes. So till the last session we have seen so many different types of addressing modes. Now we are going to discuss further few more addressing modes today. So let's begin the session with the agenda that what exactly types of mode we are going to discuss today. So today I am going to discuss a PC relative mode, then I'm going to discuss base register mode, then I'm going to discuss index based displacement mode and scaled mode. These are four addressing modes I'm going to discuss today. So without further delay, let me first tell you a few things and after that I will be going for the lecture. Okay, so here my profile. If you have seen my lectures before, that's well and good. If not, then my name is Vishwadeep. I have written GATE exam multiple times in computer science, and this is my highest rank till now. And I have written multiple times means this was my final year rank in engineering final year. 682 I got in third year, then 119 I got somewhere after that, and then I have got 440 also. And there are certain more exam result I am having all India rank these in GATE Computer Science. Further, I have done two times MTech. First is from IIC Bangalore, another MTech from the BITS Pillani for the data science. Yes, trending technology. If you guys are preparing for GATE exam and if you want to be very serious about your preparation, then it will be good enough for you guys to come to Unacademy Plus. What is the benefit? Benefit is there are so many benefits. The best benefit you can have is you will have the structured course, plus you will be having well organized preparation. And why it is needed? Just now just now I have seen the brochure given by the GATE conducting committee by IIT Mumbai, and they have introduced another type of questions this year in their paper. So those type of questions will have four options, but among four options this time not only one but multiple answers can be correct, which means you need to be very sure, very peculiar, very particular about your options to be chosen. Just because few questions will have only one answer correct, few questions will have multiple answers correct, in that case you need to choose that which particular question will have more answers correct and which questions will have only one answer correct. That will be very tough. So to face such kind of tough situation, you will need very structured preparation, very deep knowledge of the topic, and very well organized study you need to have. And for that we will help you here in Unacademy Plus. So what you can do, you take the Unacademy Plus subscription using this code VDEEP10 and you can get 10% discount. Apart from whatever I have given you, what are the benefits you can have in the Unacademy Plus subscription? Both the language classes, live classes, of course, very interactive. I am answering almost 50 to 60 questions per session of 1.5 hour per day. Yes, 1.5 hour, 90 minutes, but 60 questions I am answering for the doubts during the classroom only. That much interactive sessions those will be. Apart from that, weekly test I am going to conduct, so the students will be benefited by their assessment key. Last week whatever you have studied, that will be assessed immediately. Then I am throwing students lots of practice problems so that people will be ready to solve so many problems which are really good in the level. Every fourth class is doubt clearing class. At the end we are going to have crash courses so that revision can happen. Every single thing is available under single subscription, which is an Academy Plus subscription. And that will not be too much, seriously. If you want to take it, go for this goal, GATE subscription, and then choose how many month subscription you want to take, and use this code VD10 so that you can get the 10% ka discount. And why this needed? Just because the level of date has become tougher and tougher and tougher this year. Yes, multiple times I have used this word tougher just because it is going to be tough. Three types of questions they are going to ask. MCQs, one with one answer. MCQs, so MCQs with only one answer, right? Till now this was the pattern. Now they are going to have the MCQs with more than one answer, one or more answers. Means you need to tick mark all those answers which are correct for that MCQs, and definitely numerical type answer question. So that these two were there already. This particular thing they have added this year to make this exam more and more tough. So good evening everyone, welcome everyone. Whoever have joined here, I'm telling you these three types of questions are going to come this year in the GATE exam, and this has become very tough. So you need to be very sincere about your preparation, and hence what you can do is best option is you just join Unacademy Plus. There you will be having your preparation on the top notch. Use this code VDEEP10 if you want to talk to me. Arey, this is my contact number, my personal number. You just drop me a message on WhatsApp, drop me a text message that you want to talk, and I will call you. So if you want to know that how to prepare, from where to prepare, इतना course हो गया है, इतना बचा है, then what to do in that case, let's do this. So what happens? There are so many non-CS students also. They are also trying to prepare for the GATE exam in the computer science. As last year one person from mechanical has scored 7th rank. So if you want to get the same kind of preparation, definitely you need to be on the top notch in your preparation, right? And that fellow, he was one of my students only, mechanical from the background, and then he got 7th rank. So if you want that, you want to have the best preparation, please contact me. I will be helping you out that how you can exactly prepare. And then if you want to join Unacademy Plus as soon as possible, you join, just because already my batch started 15 days ago, some 20 days ago. The batch is not too far away from your reach. If you start early, you will be able to grab all those concepts which have been covered, and remaining concepts also you will be able to cover in the live classes, right? So contact me immediately if you want to have more assistance. And along with this particular code, if you will be using my code for Unacademy Plus subscription, of course lots of benefits. Apart from that, you will be having personal mentorship from a person who has cracked the GATE in computer science multiple times, along with 5-6 ranks under the 1000, under 1000 5-6 ranks. Yes, correct. So if you really interested to take it out, just contact me. Fine, let's go further. So if you are here, like the video, subscribe the channel, घंटी बजा दो ताकि आपको रोज सब्सक्रिप्शन आते रहें. This particular my class is daily 6 to 7 p.m. apart from Sundays, so you can join this class live for more and more learning. Fine. Okay. So, Arpan, if you are listening here, just contact me. I'll be telling you what sequence to follow, how to follow, from where to follow, and every single thing I'll be telling you. Just because here it's not the channel to just mentor one particular person. Okay. So let's start with the next type of mode which we have discussed apart from those. So yesterday, whatever the last mode we have discussed, yesterday's last mode we have discussed was this one. The mode was base plus index register mode, right? In that mode, I explained you that in the instruction I was not keeping anything. Base also I was taking from the register, and index also I was taking from the register only. So both the things taken from the register, added, got the effective address. Now today we are going to discuss a little more detailed variant of it, index plus base register plus displacement mode. अब ये क्या बला है भाई, ये क्या चीज आ गई, अरे आराम से समझ में आएगा, एवरीथिंग यू विल अंडरस्टैंड, एवरीथिंग इजीली यू विल अंडरस्टैंड, जस्ट कॉन्सेंट्रेट एंड बी विद मी, आई विल एक्सप्लेन यू एवरीथिंग, जस्ट लिसन. Suppose if you are aware of structures in the C programming language, then for you it will be very easy to understand this. So suppose you have a structure or a record, and in that particular record you have one particular record, suppose of student only you are having. Each record contains student ka roll number, then students suppose age, and then at the end you have students fee. So this is one record. This roll number is an integer, this particular age is also suppose integer, and this fee is float. And such kind of record you have for student. And now if you have taken such kind of record for some more number of students, like 5 students, 10 students, 20 students, like in your C programming, suppose you have taken the array of records. Array of records means you will be having same three things for multiple students. For first student you will be having one roll number, one age, one fee. For second student, same roll number, age, fee. Third also roll number, age, fee, and so on. So if you have taken an array of records, I am just explaining that in horizontal manner just because I am having space little less here. Okay, so let's see. If you are having an array of records like this, so first of all, this is the first record, then next record, then next record, and it continues. Multiple records you are having, right? This is the first record. In first record, what you will be having? In the first record, you will be having a roll number, then you will be having an age, then you will be having fee. Similarly, for next student also, you will be having one roll number, one age, and a fee. Similarly, for next student, you will be having a roll number and age and fee, and it continues. Okay, so let me make this bifurcation little better. So I'm making a red line here so that I can understand these records are from here to here. Let's see. Let's see if you are having this particular record as the element first one of the array. First one of the array means index 0. This will be index 1. This will be index 2, and so on. So if you are not able to imagine what exactly I'm trying to say this. You are having a struct student. Under that you are having three members. One is integer roll number, don't mind this capital R and small r please, then integer age, then float fee, semicolon, and then in the void main you have created an array of this structure like this: struct student s, suppose 10 elements you have created. So the variable name is s, array name is s, and under that name I am having 10 elements of this structure type. Now if you are able to understand this, listen now, you will be able to understand this also. Previously, to get the element we were adding, to get the element of the array, we were adding two things, index and base, right? We were adding two things, base and index. If I am also having, here also I am having, here also I am having an array of elements. If I will be doing, if I will be doing base plus index, what I can get? If I'll be doing base plus index, what I can get? I can get through this a record. What I can get is a record. Record means if I want to reach to the record of student S0, 0th index or first index or this one. So by adding base plus index, this is the base. Okay, base plus index, I can reach either to here or here, starting address of next record or a starting address of next record also. But if suppose I want to access, if suppose I want to access a specific element, a specific member of the, a specific member of the array, then how will I do that? Suppose my statement is like this: I want to access s2 dot fee. I want to access this. How can I access a specific member within the specific array element? For that particular case, suppose by adding base plus index, I have reached here. Now from here to reach to the fee, I'll have to add further more thing, and which is nothing but a displacement D. So in this, I'll have to add one more thing, displacement D, and it will give me address of a member of record. So specifically, if I want to get the member of a specific record, then I can use this particular mode, which is base index displacement. Now from where I'll be getting base and index and displacement? Okay, I will tell you. मैं बताता हूँ आप लोगों को, मैं बताता हूँ आप लोगों को. If I'll be using this particular mode, then within the instruction, I'll be getting three things. One is opcode, another thing is mode, and another thing is address. To add three things, right? I'll be having two registers. One is base register. That base register will hold the base value, base address value of the entire structure. Then I'll be having index. That particular index will be holding the index register, or the index register will be holding the index value, and I will be getting displacement from. So here in the address part, I'll be keeping the displacement value. And what is this displacement? Adding the displacement can get me to the specific element, specific member of the structure. So if somebody will ask you, what is the effective address formula? What is the effective address formula for this mode? Which mode? Displacement mode, base register, index register, displacement mode. Then effective address you will calculate by this formula. Effective address is equal to, first of all, base register value, base register value plus index register value plus displacement, which is the address field value of instruction. Are you able to understand here or not? Can you please type down that did you understand it or not? Are you able to understand till here or not? Can you please type down so that I can understand you are understanding or not? So this is the base plus index register, comma, displacement mode. And this also used to access the array of records. It is used to access the array of records. So I'm writing here why it is used. This particular mode is used. So if you guys want to know or want to get this particular PDF, you need to contact me. If you will send me a message on my Telegram channel, then I will be sending you the notes. These live notes I'll be sending as PDF immediately. As soon as possible, I'll be sending you, but you need to contact me if you are interested to get these PDFs. So mode is used to access array of records. Access array of records. So I hope you guys are able to understand till now. Let's go further and let's try to understand another mode called as scaled mode. If you remember my previous lecture, in my previous lecture I explained you one thing, and that is if you want to get the address of an element of array, address of suppose a of some I, then in that case I was doing this base plus index I into w. And what was the w? W was nothing but the word size or the element size. How many locations are used to store the element in the memory, right? And then in the few modes, whatever previously 3 4 modes I have used, indexed mode, index plus base register mode, plus this one also index plus base register plus displacement mode. All these modes were using index as this I into w. Till now index means I into w, which means before this base plus index comes, before that one instruction was needed to perform I into W operation completely. So one operation was done, one instruction actually executed to perform this operation I into W, and copied that value into index register. And after that what was happening, after that base plus index value we were using in all those modes, we were using that. What happens what happens in this scaled mode? What scaled mode says is, if you are using the scaled mode, then the instruction will look like this, that you will be having an opcode, you will be having a mode and an address. This is a small variant, you can understand. It is a variant or not, I should say variant. It's like an upgrade of register, not register, upgrade of index register mode. So here what happens, if the mode is specified as scaled mode by the binary combination, then we will take, of course, this address part as base address, of course, same cheese, same to same thing. Then we will be having this index register that will hold the index value, and there will be an implicit w value, implicitly taken a w value, which here is called as scaling factor. What it will be called as? Scaling factor. And that particular scaling factor is used to perform this. So how exactly the effective address is calculated? Effective address is calculated by a simple formula like this. Effective address is equal to base, which is address part of instruction, so I am writing here the same thing, address field value of instruction plus index register value into scaling factor. and this scaling factor this scaling factor will be taken implicitly. जी हाँ, it will be taken implicitly by the CPU. Now see, what is the difference from here to the previous mode? What is the difference? Why we are saying it's an upgrade? See, one instruction you are executing completely, and that instruction is calculating I into W, and after that it is storing the value of that I into W in index register. After that, next instruction comes. In the next instruction you are getting the effective address by adding two values, base plus this multiplication का result. So two instructions needed actually to get the operand from the memory for an array access. Two instructions, one for calculating only I into W and one for other. Now, what happens? The difference is if you are executing two instructions, look at this. This is very thin, very thin information I'm going to provide you here. If you are having two instructions, first instruction will be fetched, yes. Decoded, yes. Effective address calculation, something will be done. Execution, yes. Operand fetch and write back, and something will happen. Yes. Complete instruction cycle needed for first instruction, yes. Second instruction, yes. So two instructions, both the instructions will take some instruction cycles. Two instruction cycles will be needed to execute those two instructions. Now the same thing what I am doing. Same thing what I am doing, only one instruction? Yes, only one instruction. Means only one time fetch? Yes. Only one time decode? Yes. When effective address is calculated, at that time only extra one operation. What type of operation? ये वाला multiplication. This multiplication will be one extra operation, and my work is better than the previous one. Better means my work will be done in less time. So scaled mode is better than indexed mode. Yes. Why? Just because it is it is reducing number of instruction. How? Previously we were using one instruction only to calculate index and index into W. This, and here I am not having extra instruction to calculate it. I hope you are clear about this particular information. Remember this, these kind of information may be needed this year's GATE exam, just because the exam has become tougher this year. If you are aware, well and good. If not, then you need to check execution. This particular exam this year has become little tougher. They have added another type of questions, which are the question MCQs with multiple answers correct. Okay, so you need to be very precise this time for your preparation. Check. So next one is, okay, type down till now ki everything is clear or not, so that I can go further. Next, PC relative mode. This particular mode is used for branch statements. Used for branch instructions. Okay. So first of all, I'll explain you what is a branch instruction and what are the other terminologies related to this branch instruction. And after that, I will explain you that how this PC relative mode will work. You will enjoy this particular process, but for that you need to be with me. You need to interact with me, yaar. You need to talk to me कि you are understanding or not. You need to ask few things कि sir ये कैसे हो गया, how it has happened. You need to talk. Fine. Okay. So let me take some example. With that example and few things, I'll be explaining you how this mode works. Fine. So let's say right now I am going to ask so many questions from you. Okay. So you need to be very attentive this time. Very attentive. See, this is the memory where my so many instructions are stored. So many. So here suppose there is a program stored. In that you have instruction number 1, then you have instruction number 2, then you have instruction number 3, then instruction number 4, instruction number 5 and 6 and 7 and so on. So many instructions are there. right? So this is a program which is stored in the memory, which my intention is to execute in the memory. Fine. Okay, now listen, I'm just assuming, everything is assumption, so please just understand, all these are assumptions. I1 instruction is stored starting from location 500, and each instruction is stored on 4 locations. Again assumption, 4 locations each instruction is stored. So next instruction will start from 504, of course. Next will start from 508. Next will start from 512. Next will start from 516. And next will start from 520. And next will start from 524, and so on. All those other instructions are stored in the memory. So if you are fine till now, okay, I will be assuming few more things for the explanation of this mode and explanation of branch type instructions. This is very informative mode, informative, what should I say, a specific time in which you can learn lots of things about this course, lots of things about branch type of instructions, how they work, how they go further in the executions and all. So be with me and stay with me. Just listen and understand what exactly I'm going to explain. Fine. So in PC relative mode, I'm talking about a branch type instruction, and let's assume that right now CPU is executing instruction I2. Which instruction? I2. If instruction I2 is being executed, आप ही बताओ. You only tell me what should be the value of PC. Type down, send it. What should be the value of PC? PC should point to the next instruction's address. So PC should be at that time next instruction ka address. I2's next is I3. I3's address is 508. So PC value should be 508. So when CPU has fetched I2, PC values PC value incremented to 508. Now CPU is decoding this instruction I2. Now CPU is decoding instruction I2. Let's see what happens. Suppose in decode phase, in decode phase, CPU detects that I2 is a branch instruction. I2 is a branch instruction. Okay. To explain you more details about the branch instruction, I am assuming that this I2 branch instruction is a conditional branch, conditional one, so that I can explain you what I wanted to. Conditional means, conditional means we will have to check a condition. Agar condition true, if the condition is true, take the jump. If condition is not true, don't take the jump. That is the conditional branch instruction motive. So in the conditional branch instruction, we need to check now the condition. Where we will check the condition? We will check the condition in the execution phase. So look at this. Assume something like this. Imagine something like this. One instruction CPU has fetched. So value of program counter increased to next instruction 508. Now CPU has decoded. In the decode of that instruction I2, CPU detects that the instruction I2 is a branch type instruction. Now the next thing is CPU will have to check what? CPU will have to check that this particular branch instruction will take the branch or not. Means the condition is true or not. That particular condition will be checked in the execution phase. याद रखिए, it will be checked in the execution phase. So this instruction will be executed further. Now from the branch instruction, which is the conditional one, there are two types of options possible. One option is condition is true, another option is condition false. So I can have the condition true or false. Now what happens in those two cases? What happens in those two cases? Suppose condition true, condition false. If condition true means jump hoga, yes, of course, there will be a jump. And if condition is false, jump hoga, no, condition will be false, means don't jump. If condition is true, that particular case in technical terms known as branch taken. What it is known as branch taken. Second, next thing is this condition false. I can say branch not taken means I am not jumping exactly. Technical terms these are. If branch is not taken, you only tell me after I2 which instruction to be executed next. If you are not jumping, means whatever the instruction comes in the sequence that only you execute. Means I3 means PC value should be updated by anything. No any update. So if branch is not taken, then I am writing a statement here. I am writing a statement here. Let me write in red color pen. Next instruction in the sequence. Next instruction in the sequence is executed, which means executed next. So after I2, whatever the next in the sequence that will be executed, which means no change in PC value. प्रोग्राम काउंटर की वैल्यू में कोई भी बदलाव नहीं आएगा. Now, if the branch is taken, what happens in that case? If the branch is taken, then what happens in that case? We need to take a jump. So I am assuming that I2 instruction is taking a jump to this instruction I6. Just assume. Suppose I2 is taking a jump to I6. What happens in that case? When the branch is taken, then I am writing the statement. The I6 is executed, which is known as target instruction. Target instruction I6. Assume it is I6. Executed. If that is the case, if the target instruction is executed next, if target instruction is executed next I6, I6 is the target instruction, it is executed next, then where it is stored? At 520. So what is the target address? The target address is the address where this instruction is stored, which is 520, and that should be the effective address for the branch type instructions. I told you in definition also, in the branch type instructions, target address is the address where to take the jump. That is the effective address. So effective address is 520. And how we will calculate this address? How we will calculate this target address? It's very simple thing. Look at this. After I2, how many locations you are skipping? You are skipping locations, 4 location for I3, 4 location for I4, 4 location for I5. 3 instructions and their total 12 locations you are skipping. Sorry, yes, 4 into 3, 12 locations. Yes, 12 locations you are skipping for 3 instructions. So to get this target address, what you get is you add current program counter value, add current program counter value and this value 12, which is 508 is the current program counter value, plus 12, answer is 520. Answer is 520. That 520 will be the target address, and this target address will be copied into program counter. So at the end, program counter will be updated by this target address 520, so that once this instruction is completed I2, next instruction fetch will happen from address 520, means I6 will be executed next, बीच के सारे instructions skipped. Now, to get this value 520, what exactly we did? What we exactly did, we added program counter value and we added a value 12, and that value was nothing but how many relative locations I will have to skip, how many relative locations I will have to skip to reach to the target. So I had to skip 4 plus 4 plus 4, total 12 locations to reach to the target. Hence, I have added 12. Right? So if you have a PC relative mode, in the PC relative mode, what you add? Two things. So in the PC relative mode, you add two things. One is the current program counter value, and the second one is relative number of locations to skip. Now suppose, now suppose this is the instruction which has an opcode of some branch type. Then we have a mode of PC relative type, and we have address. Suppose for this instruction mode is PC relative, then of course you can get target address by what? Target address or effective address you can get by adding two things, program counter value plus relative number of locations to skip. So program counter to program counter से मिल जाएगा. It is a register, special purpose register. You can get it from there. From where you will take the value of this part, value of relative locations, this particular part 12, from where you will take, and that you will take from this address part. Within the address part, that number of locations to skip will be mentioned. Yes. So in the PC relative mode, how will you get the effective address? So if you want to know how you get the effective address in the PC relative mode, formula will be very simple. Effective address is equal to current program counter value plus address field value of instruction. Address field value of instruction. And what will be there in this address field value of instruction? इसमें होगा एक ही चीज, and that is nothing but the relative locations to skip. How many relative number of locations to skip to reach to the target. And this relative number of locations to skip in some of the implementation is called as offset also. So याद रखें, it's not a very different kind of term, it's very simple term. Sometimes it is called as offset also. And what is relative number of locations? To reach to the target address, to reach to the target address, target instructions, how many in between relative locations from this one to this one, how many relative number of locations to be skipped so that we can reach to the target. Fine. So if you guys are clear about this, if you are clear about this, let me know so that I can go further. Okay, one more thing, this PC relative mode is having another name. Yes, it is having another name. Another name is what? Position independent. Position independent mode. Why? Just because you keep it anywhere. You keep it anywhere, and you will be able to, manage, you will be able to run this type of instruction, as it is. So if suppose I2 is started from 504, then after 8 locations or after 12 location only I6 will be available. If I2 is stored on a location, suppose 704, and after 12 locations only you will be getting the target I6. So always you will be getting I2 to I6, 12 locations away, the I6 will be from I2. So anywhere you keep this program in the memory, there will not be any problem. This particular mode will work as position independent. Okay, so this PC relative mode, one more point I can write here. This mode is used. This mode is used for intra-segment intra-segment jump. Intra-segment jump means the instruction, the branch instruction I2 and the target instruction I6, both are in the same piece of code, same segment. They are not kept in two different segments. Yes. So both are in the same segment. Now, if suppose we want to go for inter-segment jumping. Inter-segment means one instruction in one segment, another instruction is somewhere else. Somewhere else means in some other segment, then we need to use this base register. So this particular base register mode is used for inter-segment branching or inter-segment jumping. Inter-segment jumping. Fine. Now, what is the difference from here to here? In this way, in this particular mode, what we do is we know from the current location, from the current instruction, how much distant away the target instruction is. We know that. That's why we add program counter value. That's why we add program counter value in the offset. In the offset. But here in the base register mode, now what happens? In the base register mode, what happens? Okay, let me tell you with some diagrammatic way so that you can understand it. A graphical way you will be able to understand easily. Suppose there is an instruction here in this particular segment, which is a branch instruction, this one. So here is another segment we have. This is the segment. Right, here is the branch type instruction, and that instruction wants to jump to some other instruction which is somewhere else, means that particular segment is different. This is other segment. In other segment, other instruction which is the target instruction, that is here. Now what happens? Now what happens to jump from one segment to another segment? As of now, within the instruction, I can have only displacement. What I can have is only offset, and the instruction, target instruction, is not within this segment only. So I'll have to check key from this particular base of this segment, how much distant away this target is, how much distant away this target is. So how I'll get the target address in this one? In this one, instead of using PC value to get the target address, I'll be using another register called as base register. Called as base register. So base register value, which will hold this time what? Which will hold base address of this target segment plus what? Offset. एंड फ्रॉम वेयर वी विल बी गेटिंग दीज टू थिंग्स? कहाँ से मिलेंगी ये चीजें? बड़ा ही आसान है सर, बहुत ही आसान है, बहुत ही आसान है। आसान क्या है? हियर इज ऑपकोड, here is mode, here is address part. Right, this is the instruction. Within the instruction, if mode is base register mode, this address part, this particular address part will get the offset for you, and there will be a register called as base register. What it will be called as? Base register. And it will be holding what? It will be holding the base address of this target segment. It will hold the base address of target segment. Now listen, here is another information for you. What? This target segment can be relocated. Yes. If it is relocated somewhere else, its base address will change. Yes. Its base address, where I'll have to update? In the base register. Should I update anything in the instruction? Nothing. So if somebody will ask you which addressing mode will help in the relocation without changing the instruction. Relocation, Without changing the instruction, I can name this base register mode. In fact, you can name PC relative mode also. You don't have to change anything in this one and in this one in the case of if relocation happens. Right? I hope you will be remembering this particular point. And now let's go for classification of different modes. So whatever the classification I'm doing based on a specific criteria, that criteria is what you will know in just a minute. So you are having as of now two modes or two classes of the addressing modes. First class is computable modes and the second class is non-computable. Okay, so what is computable and non-computable? Computable means some kind of computation is required. Some kind of computation is required to get the effective address. याद रखिए effective address, not the operand. To get the effective address, if any computation required, maybe an addition, maybe subtraction, increment, decrement, multiplication, any kind of computation required to calculate the effective address, then you will be having mode type is computable. If no any computation required, then non-computable. Okay, what are the examples? First I'll write the non-computable. Easy है थोड़ा, easy है थोड़ा, easy है, easy है, easy है. देखिए क्या है easy. What are the modes I am having in this particular non-computable? First one, implied mode, of course, no computation required. Then immediate mode, then you will be having register mode, then you will be having register indirect mode, then you will be having direct mode, and at the end you will be having indirect mode. All these are non-computable type of modes. No any computation like addition, subtraction or something required to get the operand. Oh, line बनाई गई. Fine. In the computable, we have studied so many in the computable. So many in this computable we have studied. What are those? The first one we have studied is auto increment decrement mode. Auto increment, auto decrement mode. In this, some computation required. Yes, increment decrement required. Then we have studied indexed mode or index register mode. Then we have studied index plus base register mode. Yes. And then we have studied index plus base register plus displacement mode. Then we have studied scaled mode. And then last two we have studied PC relative mode, which is known as position independent mode also. And one last we have studied base register mode. Now, another category we have of the classification, and that category is this, that these last two, ये जो आखिरी के दो हैं, these last two are used for branching, means to calculate the target address in the branch statements. So these two are used for branching, and remaining all are used for what? To get the operand. So remaining all are used for operand. Hello, welcome. Hello, Akshay, welcome. So these last two are used for the branching, sometimes known as control modes also, just because they are controlling the execution of instructions, and remaining all are used for getting the operands for computation. Computation means addition, subtraction, multiplication, division, and or copying from one location to another location and something. Means for data access. For data access. Right? So if you are fine with this classification, then we are having an example, but I want to hold this example for tomorrow. Why? Just because tomorrow I'll be explaining you that if you will be having one particular given scenario, based on that, in different modes, what will be the effective address and the operand value. Once you will understand this example, then I am pretty sure that you will be definitely understanding each and every mode. So what I will recommend you, before you come to the next class, I will ask you to go through all the basic addressing modes. All the basic addressing modes you need to go through, so that you'll be able to understand this particular example, and based on that you will be able to give the answer of so many questions. So I have collected some previous year gate question, and I have created some free questions for you for the practice purpose, so that I can give you those questions. So tomorrow we are going to practice all those questions. Before that, you need to understand this, that we are having 4 sessions per day on YouTube. If you are listening here, 4 sessions we are having on YouTube for free for GATE Computer Science. What are those 4 sessions? 4 sessions are morning. In the morning, we are having computer network. Then in the evening, we are having 6 to 7. One more before this computer network. In the morning, you are having TOC running, computer network running, then COA running, my course in the evening 6 to 7, and at the end, you are having discrete math running. So 4 courses are running parallel on this particular channel live for GATE Computer Science. So if you or your friend, anybody wants to join these sessions live or want to listen those lectures recorded, please recommend this particular channel to those people. So TOC right now running live from 7 to 8 a.m. and then we are going to have this particular computer network 8:30 a.m. to 10 a.m. Then COA, of course, you are listening right now to me only 6 to 7 p.m. daily, and then discrete math 7:30 p.m. to 9 p.m. Apart from that, if you are interested in learning machine learning, yes, थोड़ा fascinating word है ना? Yes, machine learning classes are also going on in the night 9:30 to 10:30 p.m. Yes. So you can learn basic Python and how machine learning is used and all those things on the YouTube on the same channel for the free, which is 9:30 to 10:30 p.m. You can access those lectures also. If you want to know more about gate preparation or anything, you want to be connected with me, then you can have multiple options. This Facebook, Instagram, Telegram, this is my Telegram personal ID. You can contact me for any kind of detail. In fact, you can call me on the number 7899 312226. That is my personal number. On that number you can message me or you can call, so that we can discuss about your preparation plan. And if you are keen to know or keen to take the subscription, then use this code VDEEP10 and use this code, get the 10% discount and get plus subscription, Unacademy plus subscription. Okay, so till then, again we will meet tomorrow with more questions. We are going to solve only questions on the addressing modes tomorrow. Then till then, happy learning, keep learning, be happy.